All right, guys, welcome back, and I want to first of all thank you for following as we are moving. You know, we are on a very complex topic, which is statistics, and we've just gone through the archive here. We distributed the information. We were able to look at the archive, and now we want to go into the question proper that is relating to the histogram. So what's the histogram? The histogram is a bar graph. Understand that it's one way of actually pictorial way of showing distribution or actually giving data out. So you see, you go to some offices or some schools, you see the number of boys and girls and compared with this bar graph. That's the histogram. So the histogram, the bars are actually hinged together. There's no space between the histogram. That's the property of the histogram. It is different from the bar graph. The bar graph, you now find out the bar chart you call, that is the one that has the space between. So let's try to differentiate the two. The histogram do not have any space between, and the width of the bars are all equal. Now the height of the bar varies because of the frequencies vary, but the width of the bar must be the same. That's the difference between the bar graph, which is the bar chart, and the histogram. The histogram, there is no space between the bars, but the bar chart, you have space between them. So now you see the difference. Now we have the same procedure. If I want to draw an histogram, I'm going to ensure that the upper class boundary, you already know how to get an upper class boundary. The upper class boundary is the one that is going to be on the x-axis. So I've got this axis labeled for you, and the y-axis, you have the frequency there. So watch the difference. When it was cumulative frequency curve we wanted to draw, which is the archive, we have to put the cumulative frequency on the y-axis, the vertical axis I mean, and we place in the upper class boundary on the horizontal axis. So the same procedure here. The difference is that on the vertical axis we are not going to put the cumulative frequency like in the case of the archive. Watch out the difference. And the histogram, we put the frequency. So I'm using these values now, not the cumulative frequency. The cumulative frequency, I put it for the cumulative frequency curve, which is the archive, and the upper class boundary. So it's like they have a common denominator, the archive and the histogram. Both of them, the x-axis are going to contain the upper class boundaries, and the vertical axis is what brings the variation. The variation is that for archive, the cumulative frequency is the one that is plotted along the vertical axis, which is the y-axis, and for histogram, the frequency is the one that is plotted along the vertical axis, which is the y-axis. So note the difference. But when the x-axis are all going to be the same for both archive and histogram, the upper class boundary will be on this x-axis and the frequency on the vertical axis. So note the difference. So I'm going to look at the frequency column. The highest number there is 10. So I have 12 boxes on the graph paper, standard wire graph paper. You have 2 centimeters to whatever unit that is there. So you must check. You must make sure you make use of 3/4 of the graph paper. So there are 12 boxes on that vertical part of the graph paper, so I can use 10 of them. So I can stick my 2 centimeter to 1 unit, 2 centimeter to 1 unit, 2 centimeter to 1 unit, like that. 4, this is 5, this is 6, this is 7, this is 8 and 9, then I have 10. This is 2 centimeter to 1 unit I've used for this scale here, because I have the highest frequency must have a space there, and the lowest frequency must also have a point somewhere there. So you must be able to locate the lowest frequency and the upper frequency, the highest frequency there. You must have a way of adjusting your scale to get it. This scale is open for you, but you must ensure that the lower number, the lower frequency must be plotted and the upper frequency must be plotted, and you must use 3/4 of the graph paper so that your work becomes very clear and readable. So now we look at the upper class boundary. So the same, now it's a bar graph, so it's going to be between this upper class boundary corresponding to this frequency. So now I look at number 1, is corresponding to this frequency, that is 4.5 is 1, 4.5 and 1. So we have 9.5 and 5, 9.5 and 5. So I can be using my ruler, 9.5 and 5. So I get there. This is 5. So we get there. This is 9.5. So this is 5. And you have 10. So I get there, 10. So this is 10 up there. So that is 10. And that's this. This is 14.5, 10. That is 14.5, 10. That's the frequency. Now we kept to 9, 9 again. 9 is 19.5 is 9. So you use your own ruler. This is 9. And this is there. So I get that point. This is 9. This is 9, 19.5. So I go to 5. 5. This is 5. This is 5. This is 5. There. So I've got all the bars intact. So you can see that the bars are basically of the same width. The width are the same. So it's the height that differs. So I've got the width the same. It's the height that differs. So that is the graph for you. So I've got the histogram. The histogram, you see, it tells you that, you see, the highest bar is always towards the center. That's why this topic is called the measure of central tendencies. All these mean, mode, and all of them are going to be pushing towards the center. That is the topic itself. It's called measure of central tendency. So you can see the highest bar is going to be squeezed between is always going to be towards the center of this distribution. So now let's check that. Now this is what is called a histogram. Watch the bars, all the width of the bars are the same. This width is equal to this width, is equal to that. The height of the bar, it varies with these numbers, but the width of the bars must be the same. You, the one selecting your width, no problem, but they must ensure that the width of the bars are the same. Now the height of the bar is because of these numbers. So now this is called a histogram. Now the question says, draw the histogram. We've done that already. Now it says use the histogram to estimate the mode. The mode is the highest occurring number, in other words, the highest occurring frequency here. So we check through here. It is between 10 and 14. This is the highest frequency, but there is a number. There are 5 numbers from here, from 10 to 14. There are 5 numbers there: 10, 11, 12, 13, 14. And amongst these 5 numbers, there were 10 other numbers that occur here that they're ranging between 10 and 14. So there are 10 numbers in there. So now it's possible that these 10 numbers, 3 of them can be 11, or 4 of them can be 13, or even 9 of them can be 12. So the highest of them inside here is what you want to verify there. That's called the mode, the highest occurring frequency here. So amongst these 10 numbers, which is ranging from 10 to 14, there's 11 there, there's a 12 there, there's a 13 there. So amongst those numbers, there is one that is occurring much more frequent. That's the highest. So we look at it for that is called the mode. The mode is the highest occurring frequency, or the number of them. So how do I get the mode? We are going to get it from the highest bar, because it's inside the modal. This is the modal class. If you're asked to show the modal class, this is the modal class. This is the class that contains the highest frequency. That's what is called the modal class, 10 to 14. Now we want to find the mode from this. So we get it from the modal class. It's inside this highest bar. So we check you take your ruler and do this. You are going to locate first of all the highest bar. And now you look at the 2 bars that are adjacent the highest bar. And where they are touching that highest bar, you try to locate it in the opposite or the opposite diagonals. You drain them from that. This one goes. You can do that with dotted lines or thick lines like I'm doing. Then I connect this other point to there. So it connects to that. Yes, this is where it's touching it. It's touching it here. This bar is touching here, and this other bar is touching here. It is not this end to there, or this end to there. It's not that. It's because this distance to there and this to there. That's how it's connected. Now you take your ruler, you put it right here, and go down, down. It's going to touch a number. It's going to touch a number on that axis, down, down, down. So it touches a number there. Let's say that's it. It's touching a number here. This is 9.5. This is 10.5. This is 11.5. This is 12.5. This is 13.5. This is 14.5. So it is touching, let's say it's touching 13.5. This is 9.5. this is 10.5, this is 11.5, this is 12.5. So this guy is touching 12.5 from my own graph paper. So I can say my mode is given by 12.5 from my own graph paper. Now, if I am a meticulous student that want to actually find the correct mode here, I'll use the formula to ensure to see whether this my mode I've selected is correct. So I'll use the formula. So the formula says you are not expected to use the formula in this, but it's just to verify that this is your mode you have collected here. This mode is correct. This is 12.5 is a correct figure. You know, it's actually within here. So 12.5 is still inside the moded class. So it could be that it was number 12, or it could be number 13. So it could be any number. So let's say 12 in that case. So it dropped on 12. It just or somewhere around 12 here, not 12.5. It can be a whole number. It's not necessarily good to be a decimal point. It can be a whole number. So let's say it's 12 in this case. So I read it. It dropped on 12. This is 10.5, this is 11.5, and let's say it's dropping at 12 instead of 12.5. Let's say there. So now it's 12. So now I've read that for you. Now you know how to read it. First, you have to locate the highest bar. This is the highest bar. There are two other bars that will be adjacent. This point is connected to that point, and this point is connected to that point, and where they intersect, you drop the line to read this figure. This figure gives you the mode. That is the mode from on this axis. So the mode is read on that axis. So now we want to look at the way we can find the mode from a formula point of view. So if you are a meticulous student, like I told you, you can first of all find the mode by formula, and then you come on to ascertain it on the graph. It's possible. So look at that formula to estimate this mode. In fact, we can use it to verify whether our answer is correct. So now this is mode by formula is given by the lower class boundary plus this is delta 1 divided by delta 1 plus delta 2, or multiplied by C. C is the class mark. So I can define these terms for you. This is lower class boundary of the modal class, delta 1 is the frequency before the modal class, the modal frequency. Let's say the frequency before the modal frequency, if you like. To delta 2 is frequency after or above after the modal frequency. Now we have C is the class mark. This is the class mark. It's a class mark or class interval, if you like. Now we have defined all those terminologies for you there. So that's the formula to get the mode. So this is by formula, it's not by this structure. So now if you want to ascertain your answer here, you want to make sure you get this point properly, you get that answer correctly, you can use the formula to help you out. So I come to verify Li is the lower class boundary of the modal class. So I come to look for the modal class. The modal class is this, that's the highest frequency there. That's it. Now, what is its lower class boundary? This is the lower class boundary. This is the upper class boundary. Lower class boundary is 9.5. So I bring it here. So I'm now finding my mode by formula is equals to lower class boundary is 9.5 plus. Then I come back. This is the frequency that is before the lower class. This is the frequency before the frequency of this is the modal class. It has frequency 10. So the frequency before it is 5. That's the frequency before. So it is 5. This is it, 5. That is delta 1. That's the frequency before the modal frequency, which is this is the modal frequency. The frequency before it is 5. Now the frequency after it is the delta 2. So the delta 2 is the frequency after 8. This is 9. So what I've done here, this is 5 and this is still 5, and 9 is the frequency after the modal class. This is 9. That is the 9 there. Now I'm coming for the class interval, which is the interval between, called the class mark. So I come check the class mark. I start from this number, I end on that number, or I start from this number, end on that number. So it is a 0, there is a 1, there is a 2, there is a 3, and there is a 4. So there are 5 numbers there. The interval C is 5, not 4. It's not the difference between this number and this number. No, it is starting from this number to this number. So there are 5 numbers that should be there. This is 0. If you can count your finger, 0, 1, 2, 3, 4. 5 numbers. So it's the class mark is 5. 5 there. So I now have 9.5 plus this guy goes 5 divided by this is 14, then 5. So I have 25 all over 14, then plus 9.5. So if you now have your calculator, you can punch that with me together. We have the 2. This is 25 divided by 14. You must know how I got a 14. This is 9 plus that give me 14. This is 5 times 5 is 25. So I've got this divided by that will give me 1.78. So 1.78 this is it here. So this is 1.78, then plus 9.5. So I have 9.5. This is 9.5 plus 1.78. 1.78 will give us this 11.25. This is 11.28, sorry. So now it's 11.3 if you round it up. So you see, this gentleman, from what you read here, will not have been the correct figure for the mode. The mode is this. So it's still between 10 and 14. So this would have been the correct mode, that is 11.3. So I'll just come and look for 11.3. This is 10.5. This is 11.3. So I locate it from here. I go. So this line would have been somewhere here. It means my bars were not correct, or my scale is not correct according to here. This is, but when you do it on your graph paper, you will see the correct scales coming out. But I'm not using a graph paper, so that's why I have a small deception over there. But for you, if you want to verify this, you have to ensure that you go through the graph paper and you measure these distances there, and that could be another method for finding it. You can as well use another way of getting these numbers. You can look at the difference between the heights there. You see, this is what I was talking about. The difference between, this is the lower class boundary, that's it there, and the delta 1 is the frequency before the lower class. You can get it there. And it can also be that this distance and this distance can also be computed to get the same mode there. But I don't want to bore you up with so many formulas. So this is not supposed to be shown actually, because they told you to find the estimate the mode using the graph. That's the procedure. You locate the highest bar, you try to look at the adjacent bars that are closer to it, you connect to that point, and where they intercept, you run it down and read this number. It is just for you to confirm this number. That's why we are trying to use that formula approach, but that is not the question. We are supposed to use this bar to get the mode, but for you to verify your answer, that's why you are supposed to do that kind of stuff there. But now we want to look at the last question which will be asked, that is to now draw the frequency polygon. If you are asked to draw the frequency polygon, you can now find the midpoint of the bars. So it was supposed to be at somewhere around 2. This is this plus this divided by 2. That's give you 2. So the midpoint of this, the midpoint of the bars, midpoint of the bars, midpoint of the bars. Then you now look at, take your ruler and you try to locate, you try to draw a line. A polygon is a closed plane, is a closed plane figure bounded by a straight line. So I connect this. I connect this point to this, then I connect there to this also. I'm trying to draw the polygon. This is the frequency polygon. I connect it there. You can use straight lines. I'm just using dotted lines because of my marker. This is it, so I connect there. So this is what is called the frequency polygon. Frequency polygon. What is a polygon? It's a plane closed figure bounded by straight line. That's why you're joining them with straight lines there. It's a straight line there. So if I have to close it, then I have to drop it onto this part here. So I drop it down here so that I can close, because I drop this one to here so that I can close, because a polygon is a plain closed figure bounded by straight lines. So that is the polygon for you, and this is the mode. So you must now know how to find the mode, the histogram. The first to draw the histogram, we require the upper class boundary there, and we'll have the frequency up there, and we in identifying the mode, you have to locate the first two, the highest bar there, and the two bars that are adjacent. You connect there, and you drop the intersection. You drop and read the histogram to estimate the mode. So you are supposed to use this, but because you want to make assurance double sure, that's why you are using that formula to ensure that your mode is the proper mode. That is mode by formula, but this is mode by using the graph. So now you have to look at the technical point here. See the difference between a bar graph, which is the histogram here, and the bar charts. The bar chart, there's space between them, and this one do not have space, and the mode is estimated from the highest bar there. So note the differences over there, and the x-axis have the same variables there, the phase quantity, the same variable you have to mention. That is the upper class boundary must be over there, and for the frequency it could be on the vertical. That is for histogram. So take note of this, and I wish you can continue. I want you to keep watching as we move to the next topic. Thank you for your audience, and follow up. You try to subscribe. It's very important that you subscribe, so that when I upload a new video, you're able to see it. So try and subscribe, and you follow up as you move. That's the end of the lesson. Thank you for your audience.